Howdy everyone, this is Boone, and today I'll be going over the two weirdest worded problems in the entire I Have Tide problems list. There are 28 problems total, and these two I believe are the most difficult to understand because you are not sure what they are asking the entire time. So we got our high tide sheets here, and we're going to be working through problems 427 and 506. So we'll knock out 427 first, and then we'll do 506. 427 reads as follows. On March 23rd, 1983, at Kingston Point, New York, was at earliest time 1700 Eastern, ZD plus 5, that the predicted tide will be plus 2.0 feet. Alrighty, so it really just goes back to interpretation of the question at this point. This is the only problem that I could find on this sheet where it has a plus before the feet given. Now, this is a weird case scenario, but it's saying when will it be above 2 feet? And since that high tide problems go on the the 10th decimal place was higher than 2 is 2.1. So you have to interpret, that's how you have to interpret the problem to get the correct solution. Now I'll be showing you what I'll be putting down. So the high tide at whatever time is 2.1 feet. That is what we are solving for throughout the problem. Now we have some given information in the problem. Kingston Point, obviously a ripoff of Kings Point, decided on March 23rd, 83, after 1700, and I believe that's all the given information. It is not daylight savings time, and the ZD checks out because it is ZD plus 5. ZD plus 5 means it is in the correct tide heights meridian that we are trying to find in, so that is good. So I do like to do a ZD check over here to show if I need to account for it later in the problem, but that's showing that I account for it. So let's go find Kingston Point, New York. Cover tide heights, and then Kingston Point shows up in 4 places. Now, as I discussed in my video over how to properly navigate the reprints, 4 times it came up, so it's probably gonna be in the currents and the high tide as well. So we need to make sure we stick to the first half of the book between before page 136 of Kingston Point. So this brings us to table page 92, Kingston Point 1553, which makes sense because it says New York right here and it's high tide. So I'm pretty sure it's right, but just to double check, it says Kingston Point, New York 1553 in the index. We hit this again, it should go to ebb and floods. So we obviously know that this is not the one we're going to be using. So we're going to go previous and then previous, and we're back to 1553. So we will write that in the substation just because it's a good thing to do when you actually need the reprints and you need to keep track of that stuff. Now the reference station is New York, as I already said, but I'm just going to actually just write NY in the page number because the page number is really the only thing that matters there, as long as we know kind of where it's at. And then Kingston Point is off by a lot, but 5 hours 16 minutes for the high water difference. So I'll write this on my paper. Plus 5, 16, plus 5 hours 16 minutes, plus 5 hours 31 minutes, minus 0.9, had to double check that, and then minus 0.1. So we have all of our stuff for Kingston Point right here and our reference station that we need to go to. So now we'll go to the reference station. Good rule of thumb I like to follow also is I've just put in the reference station number and see how far off I am. I might decrease that by 10, so 46, and then I'm around the right page. It's really complicated to get around it, but you can just use your going up and down here to easily find it. And now that I'm on 56 is going to be March 23rd. March 23rd, right here on the first page. It is a Wednesday. And we are solving for after 1700. Now that we have that, let me zoom in on the Wednesday and I'll pull up my work again on the right side. Oh, perfect. Okay. So here is what box we are solving for. Now we always ignore the right side, per usual. So we're only going to be using these numbers. And it has to be after 1700. So you initially think, oh, probably between 1543 and 2205. But we have to account for the fact that we need to add in 5 hours. So it's actually going to be between 0953 and 1543. When you count for the 5-hour change, it will be that 1700 will fit between those two. So 0953 is a low water. So 0953 and 1543 is a high water. 3.7, 0.2. Then we need to add in the time change. So I like to put LW, HW, so I know exactly which one I use. 1543, 0953, and 0531. Wanted to double check. And remember, we need to solve both these sides separately of each other. I just put them next to each other because it's already in my mind to add separately. And then 1543 is 0516. Remember, that is also separate. Okay. Now we got to add both those times together. 43 plus 16 is 59. And 15 plus 5 is 20. Now, honestly, the hardest part of this problem was figuring out that you need to use 2.1 instead of 2. The rest of the problem really just works like a regular problem. You just need to think outside the box a little bit for that initial part. So now that we calculated our reference for Kingston, we're going to put these back into the substation. We need to account for the low water difference, which is minus 0.1, so that'd be 0.1 and 2059, and minus 0.9, so that would be 2.8. Alrighty, we have accounted for the reference station, and we'll pull this back over now that we don't need this side. Now that we don't need this side anymore. Alrighty, so now that we've accounted for Kingston, we need to do the rest of the problem, which we pretty much already have. 2059, 1524. And we're going to subtract these to find the duration. So 59 minus 24. I have my calculator right to the right outside the screen. 35. Then 20 minus 15 is 05. So the duration of rise and fall is 05 H 35 minute. Time from the nearest tide. We need to figure that out. The range of tide. We can't figure that out. 2.8 minus 0.1 is 2.7. Height of the nearest tide. Okay, now that we need to figure that out, and correction. We'll find both of those. So we're going to do LH, or LW, HW. Alrighty. And now that we have both of those, we're going to subtract 2.8 minus 2.1. And 2.1 minus 0.1. Now, you might be asking, why did we use 2.1 here, and on the bottom here? Because the low water and the high water are the two extremes. And 2.1, we're trying to figure out where it is along those two extremes so that we can find which one it's closer to and use that for the time, because that will be closer to one of these than the other. When you subtract 0.1, it would be 2.0, and when you subtract 0.8, it would be 0.7. So we obviously know that along this, if, for example, if this was 0.1 and 2.8, it's 2.1 is closer to 2.8 than it is 0.1, and we're using just the extremes to find where it would be closer to. If that made no sense to anyone in the last couple videos, want to clarify on that. All right, now that we obviously can tell that we found the lesser one, which is 0.7, we're gonna just square that in just so we remember, okay, we are using high water. And actually 0.7 is your correction factor. So we're going to put that in right here, 0.7. And the height of the nearest tide is going to be 2.8. Because we are using high water, so the height of the nearest tide would be 2.8. Over here, we're going to do 2059, 2.8, just how it appears right here. And we're going to put the correction, we're going to put a blank time because we don't know what time we account for yet, and 0.7. Now, to find this time, we need to use our good old friend Table 3. Table 3 will tell us exactly what we need to do from here. So the range of tide is 2.7, which 2.7 goes to 2.5 because it is closer to 2.5 than it is to 3. So 2.5, and then our correctional factor, as we just found, was 0.7 right here. Now that we have 0.7, we need to find, I'll keep my finger on that. Our duration of rise and fall is 0535, which rounds up to 0540 when looking at the duration of rise and fall chart over here. So 0540 right here, 0.7, 2.5 right here. And now we're just going to figure out where those two meet. And that would be 2 hours and 5 minutes. If that makes sense how I just did that, please send me a message and I would be glad to explain it to you again. Okay, but now that we have 205, we're going to use that right down here. So 02 hours, 05. Now we're going to subtract all of this. Now 2.8 minus 0.7, we pretty much already found that. We knew we were solving for 2.1. What we're really solving for is the time. So 59 minus 5 is 54. And 20 minus 02 is 18. The answer that I just got was 1854. And the Coast Guard answer for this question is the exact same, 1854. That is 427. I did that decently fast while explaining it, of course. But now we're moving on to the hard one, which is 506. Now, it has a lot of information, so let's break down the question piece by piece to see what it is really asking. And as I'm doing that, I'm going to actually make my video a little bit smaller and turn it on just like that so you can see what I'm writing in and as I'm reading it. Alrighty, so 506. Let's highlight that just so I don't lose track of it. And we're going to go piece by piece. You are to sail from Elizabethport, New Jersey on 22nd May 1983 with a maximum draft of 28 feet. You will pass over an obstruction in the channel near Sandy Hook that has a depth of 26.5 feet. The steaming time from Elizabethport to the obstruction is 1 hour and 40 minutes. What is the earliest time ZD plus 4, remember that, you can sail on the afternoon of 22nd May and pass over the obstruction with a 2-foot clearance. Alrighty, that is a lot of information. Let's show what we need and don't need. You do not need to know that is from Elizabethport, New Jersey, because of another given information in there. That is just in there to confuse you. Let's actually erase that whole thing. we're going to use our handy dandy formula to find what we need to be at to find the required height. So the draft it gives us is 28 feet. The clearance it gives us is 2 feet. The charted depth is 26.5 feet. And now we need to find the actual depth of the water, or also known as the required height. Now I made up this handy dandy formula that consistently works. I just find it easier to remember than any other thing I've seen. So C plus D, clearance plus draft, minus charted depth equals RH. I like to use the parentheses just to make it easier for me to understand. So 28 plus 2, 30, minus 26.5 equals 3.5 feet. Alrighty, so that is the height we are solving for in this problem. So that just took out a maximum draft, depth of 26.5, and 2 foot clearance. Alrighty, we're making progress. So now let's put in 22nd, May 83. The time desired is earliest afternoon, which is very weirdly worded. And it's basically afternoon. Literally after noon. So early after. Okay, so now that we know is the earliest afternoon after 1200, that's when we'll be. So May 22nd, let's erase that. And the reason I'm doing it, I'm erasing parts, is because this question just has so much information that you have to eliminate some of it, otherwise you're just confusing yourself the whole time. All right. So this is an earliest time question. As you probably tell by the earliest afternoon. And now we need to really get into the theory behind this problem. And let's put 3.5 right here. Just so time is 3.5 feet. Okay, so we have everything we need. This is not daylight savings time, but this is a ZD we need to account for. So the ZD is plus 4. And since that isn't plus 5, we need to account for it. One H bar. So we need to add 1 hour because it's ZD plus 4. And to get ZD plus 4 to ZD plus 5, you simply add an hour. So one more thing though. Elizabethport is what you're sailing from, not to. You're passing over obstruction in the channel near Sandy Hook. Sandy Hook is what you're actually looking for, because Elizabethport is just where you're coming from. Sandy Hook is where the obstruction is located that you have to avoid. So, and from Elizabethport to the obstruction, so you're not anywhere near Elizabethport, so you will not need to account for anything that Elizabethport has to offer. Sandy Hook, by contrast, is its actual own reference station. So let's take Sandy Hook, and hopefully when I look it up, there we go. Exactly what I was looking for. Sandy Hook, New Jersey. Okay, cool. Sandy Hook, and actually I was on the right page. So we know this is the correct Sandy Hook, and let me make this a little bit bigger now. Actually, let's just mute this. We know this is the correct Sandy Hook because it's in the tide table. And if you go to Elizabethport, you go to Elizabethport on the reprints, it'll say on Sandy Hook, page 64. So we're going to use Sandy Hook as our point of reference throughout this problem. So Sandy Hook was on page 64. I passed it. 67, 60, 64. Okay, and we're doing May of that year. Cool. May 22nd. Right here. Let me move that over to the right a little bit, and let's copy down those numbers. And let's make this a lot bigger. There we go. So the station height that shows at the 22nd is 10, 16, 22. Now, the earliest in the afternoon is 12. 12 after 12 is the afternoon. So it would only make sense, since we're not accounting for anything other than our ZD, to use 10 and 16. So let's account for our ZD to add 1 hour right up here. Let's make that 11:22 for low water, because it's a negative 0.3 right here. 11:22 and 17:41. 17:41 is 5.1 and 10:22 is negative 0.3. Now we really don't need this substation because we're not using one. We're only going off of Sandy Hook, because that is where the obstruction is located near. And this is on page PDF 53 or /64 in the actual one. So I was right above. Okay, so now we have this. We are right near Sandy Hook, so we're getting a lot of this done. So 17:41, 11:22. Now we need to find duration of rise and fall. Time of, we will not be able to find time nearest tide, range of tide, high of nearest tide, and so on and so forth. And we're going to do that basically how we did the last problem. 17:41 minus 11:22. 41 minus 22 is 19. And 17 minus 11 is 06. So the duration of rise and fall is 06 h 19 minutes. Which makes sense because the duration of rise and fall on table 3 goes off 20-minute intervals. So time from the nearest tide, we don't know that. Range of tide, we do know that. 5.1 minus a negative 0.3, which would be plus 0.3, so that'd be 5.4. Now we need to find the height from nearest tide. We're going to do exactly what we did in the last one. We're going to take the high water and subtract out the number we're trying to find for. And the low water and subtract it from 3.5. So minus a negative 0.3. That would be 3.8, and 5.1 minus 3.5 is 1.6, and we obviously have a winner. Now that we have that, we can set up our time problem again. 17:41, just like this, 5.1, and then our correctional factor, which we just found to be 1.6, and our nearest height is 5.1. We're going to take our correctional factor out to net us 3.5 at the end of the equation. And now we just need to find our time. Well, we do that through the same method we've been doing the whole series. Table 3. Let me bring table 3 over here. And Range of tide is 5.4, which goes to 5.5. And the height and the correction factor is 1.6. The 1.6 is right here in this column. There we go. 5.5, 1.6, and then 6 hours and 19 minutes, which is 6 hours 20 minutes. So we're going to come up here. 620. 1.6 up to 219 is where we are intersecting. So I'll subtract 0 to 19. Remember, these are separate, so we need to just account for them differently. This is hours and minutes, so 41 minus 19 is going to be 22. 17 minus 2 is 15. And 5.1 minus 1.6 is going to be 3.5. We already knew that. Okay, cool. And there's your answer, you would think. But this is where the problem tries to get you one last time. This is not the answer. There is one last part of the problem we have not accounted for. But let's see what we have accounted for. We have accrued for the earliest time, ZD plus 4. Near Sandy Hook, we have accounted for that by not using reference station. But the steaming from Elizabethport to the obstruction is 1 hour and 40 minutes. That is the last thing in the entire problem we need to account for. So let's turn the camera back on. And we're going to subtract 1 hour and 40 minutes from our time. Is the time it took. And 14, 82, 82 minus 40 is 42. 14 minus 1 is 1342. 1342. And now we have officially accounted for everything in this problem. And we'll pass over the obstruction at 1342. Okay, well, this wraps up this video. This has been problems 427 and 506. I will try to add in markers where you can go back if you were confused about a part. These are probably two of the most weirdly worded, confusing problems within the entire database of high tide problems. So it makes total sense if you struggle with these or just did not know how to even interpret them because they were so confusing. But I will hope that this video has been helpful to someone watching it, and please let me know if you need any more videos done. I'd love to help. Thanks again.